The first day I released this coil, I mentioned that this coil does some pretty interesting things, and I ended the video on that note, and it was a bit of a cliffhanger. There's been a few things, and one of them I'm going to show you now, which are quite unusual and need further testing. So here I've got my night lamp. I'm just going to show you a small experiment here, and then you can put in the comments what you think is happening here. So I've got the night lamp, and I've got the Caduceus Pancake Coil on a dual fifth. This is a 5-watt light bulb, 220 volt UK mains, and I'm using my power supply, and the power supply here, the voltage is 7.6 volt. The current is actually not accurate from my power supply for some reason, so it probably is a little bit damaged. So that's why I've got an inline current meter here, a current multimeter, and so it's actually current draw is 0.325 milliamp, 0.325 amp, sorry, so it's 325 milliamp. So the experiment here tonight is that I've got here a John Bedini magnet coil, which I have described in a previous video, so check out my previous videos for this additional information here. But this is the John Bedini magnet coil, 2 North Pole magnet with a coil wrapped around. This is connected in series with the output, so essentially the dual fifth is just oscillating, and the output of the dual fifth is then connected to the magnet coil and then back to the load, and the output is going back to the dual fifth circuit. What's interesting is if I take the Caduceus Pancake Coil, and you can see the current draw here at the minute is 325 milliamps. Now if I take the coil, I'm going to try to remove it. Okay, I take the coil here and I put it flat on the magnet coil. I don't know if you can see it on the screen, but the brightness increase, and look at the current draw, it doesn't change. So perhaps that's not, yeah, you can probably about just see it here, but I'm going to show you here the current draw. So you can see the brightness of the light is fairly bright, and as I move the coil towards the magnet coil, the brightness increases, but what's interesting is the current draw stays the same. And this is one of the interesting things I wanted to show you, is conventional electromagnetic induction. When we put a coil in a field, we get a draw, we get a current draw, so we get a load effect. So our increase is nil. So what's going on is we are actually getting more power in the system for the same current draw, and this is one of the interesting effects. This is all for today. Please leave your comment in below the video, and thank you for watching.